Hi, welcome back to another episode of Real-World Serverless, a podcast where I speak with real-world practitioners and give their stories from the trenches. Today, I'm joined by Matthew Bonig, who is a Chief Cloud Architect at Defiance Digital, who are helping companies manage AWS workloads so that they can focus on doing what they do best. And Matt is AWS DevTools Hero. He's the co-author of the CDK Book, and he's recently announced a new course called Advanced CDK course. So I guess we're going to hear more about that later. Before we get into that, Matt, do you want to just say a few words and tell the audience about yourself and how you got into CDK?
Sure. Thank you so much for having me. I really appreciate it. So the CDK was a sort of odd introduction to me years ago. So I am historically an application developer. I originally started off with doing support integration for a customer, and then I got into .NET development and then eventually mean stack development. And a few years ago, I was working for Rackspace. And at the time I was working with Eric Johnson, DevRel with AWS currently. And our project sort of got canned at the last minute. We had been working on this onboarding project for a couple of years, and they decided business process changed and okay, we're going to replace it with this off-the-shelf thing. And suddenly overnight, I became a DevOps engineer and got heavy into Terraform, and I was playing around with it. And the CDK started going to preview mode, and Eric reached out to me and he said, hey, you got to check this out. I think you're going to really dig it. And my first thought looking at it was, I don't want to use an imperative language. I like my declarative syntax. I like Terraform. It's working well for me. I got no reason to change. And then it was about 6 months later, I was doing some contract work, and I ran across a sort of somewhat unique problem I haven't seen since then. I was asked to maintain the configuration of over 200 RDS databases. It was a project that was being built. There were decisions being made, and there was a reason why they wanted to have over 200 individual RDS servers across multiple accounts, across multiple environments. And each one of them had a different spec in terms of the engine that was running, whether it was MySQL or Postgres, what version they were on, and all those sorts of various dials that you have when you're creating an RDS instance, storage space, instance type, all that. And I realized really quickly that I didn't want to maintain a CloudFormation template that was that massive. I wanted to give it back to the people who were requesting this, the application developers, and say, hey, here's a spec file. Just put into this spec file whatever you want. In this case, it was a big JSON file, and then I'll take it from there. And that's where the CDK really gained a lot of traction with me, because I could read this JSON file in, and then generate all the CDK code from that. And then, of course, that got into CloudFormation, and it made it really, really simple to give the power back to the developers to choose what they wanted from an infrastructure standpoint. And then everything after that was pretty turnkey. So after that, I was hooked, and I've been involved with the community ever since.
Yeah, so I guess I can understand why you wouldn't want to use CloudFormation or any other tools to kind of template that kind of configuration, that kind of different, that number of different configurations for your RDS clusters. But I guess that with CDK, one of the biggest things I've come across certainly is that the fact that you've got this general purpose language and at your fingertip, and the CDK doesn't really impose a particular way of structuring your application. So one of the problems with CDK I've seen is that pretty much every company kind of just reinvent the wheel, and you see all kind of different like bespoke patterns and the things like that people do in their organization. And one of the ways I've seen those patterns kind of become more of a convention is when you've got agencies come in, now they do it for one customer, they discover a pattern that works for that customer, and then they move on to the next customer and do the same thing over there. Are there any other kind of like, I guess, anti-patterns or mistakes that you've seen people make with CDK? Things like what I described in terms of creating abstractions where they probably don't really know what should be abstracted, but straight away they're creating these abstraction layers and that are quite brittle.
Yeah, that's definitely probably the hardest part of the CDK is that you don't have any guardrails in place. You really can do pretty much whatever you want to because it is a general purpose language. That's one of the things that actually really brought me to the CDK was that I could do anything with it that I wanted. Being an application developer originally with .NET and then with Node and other things, I always felt very hampered by what I could do with HCL and CloudFormation and other things. And the development process and the debugging process always drove me insane, having to figure out, well, is this intrinsic function really doing what I think it's doing? And I don't really know until I do a deployment and it fails. There are certainly a lot of anti-patterns out there. Premature abstracting is certainly not a new problem that is unique to the CDK. This is just a general programming issue. And it seems to be the organizations, the teams, the people who have adopted the CDK that, like me, have come from more of a traditional application development background that already knows sort of what these issues are, how to solve them, the red flags to look out for, don't seem to struggle with it as much. Whereas, system operators and people that came from the sort of the other side of the DevOps world that came from more of the traditional infrastructure management, people who were very familiar with writing probably Terraform or Bash scripts or Perl scripts or those other types of things may struggle with it a little bit more. And it was one of the reasons why I was very adamant from day one of trying to get involved with the CDK community, because it was very clear early on, you can really shoot yourself in the foot in the very wrong way. As far as specific anti-patterns that I've seen, there are certainly a lot of code bases that I've come across that were built in a way that I wouldn't have built them, but I wouldn't necessarily call that an anti-pattern. That's just an alternative way of getting something done. Certainly some stylistic things that probably don't line up. For example, variable casing and how you pass things from stacks to constructs to Lambda functions and other things. The only real anti-pattern that I would say that I've ever come across was the use of context and using context as a configuration platform rather than really its only valuable use, in my opinion, is as a local cache. Context is a great thing, provides a lot of functionality within the CDK itself, but it's not really a great API to work with. You really have to build a lot to work with the context if you're going to use it as a local cache. The other thing that it sort of replaced
so for folks who haven't used the CDK and they're not they don't know what the context is object is, can you maybe just briefly explain what is the context object? What can you do with it?
Yeah, so context was a rather sort of big picture item within the CDK where at any point within your CDK code, you could go back to this context object and it would give you some sort of configuration information. So for example, it could tell me a VPC ID that I need to know for a given environment, or it could tell me some information about that VPC that is in a particular account or in a particular region. But it has gotten horribly abused. I certainly have abused it a few times within my own code bases to use it as sort of a synthesized parameter to say, well, here is that VPC ID that I want, and I pass it in as a context value. So context can be read and it can be generally set. So when I synthesize code, I can pass in a context value to say, A equals B, key equals value. And then later on within my CDK code, I can go back and say, okay, what is the value of this particular key? And it doesn't really function any better than just environment variables or what really should be done, which is just coding these things directly into your CDK app, stage, stack, or construct directly. Local caching is really only its real value. So my advice for most people is if you think you want to use context, you probably don't. You probably just want to code things directly in. Stay away from context as much as you can, unless you're providing L2 constructs to the CDK directly.
Okay, so I guess in that case, since you mentioned the L2 construct, again, for people who are not familiar with CDK, what do you mean by L1, L2, L3 constructs?
Yes. Okay. So in the CDK, there are generally three sort of different abstractions or categories of constructs, and we call them level 1, level 2, and level 3, or L1, L2, L3 constructs. So a level 1 construct is a generated code from the CloudFormation resource itself. So the CDK team regularly takes the CloudFormation spec, runs a tool on it, and that generates out all of the L1 constructs that exist within the CDK and ship with it. And they correspond one-to-one with the CloudFormation resource. So if you are dealing with, say, an RDS resource in CloudFormation, that maps to a CFN instance and the RDS namespace there. No magic, nothing special. It's just here's a TypeScript interface for dealing with the CloudFormation resource. Not everything, everything in CloudFormation has an L1 construct. Then you have level 2, which builds on top of an L1 construct. And an L2 construct takes that L1 thing, whatever it is, and adds in a lot of nice little wrappers and little helper functions and other things around it. So for example, if I have an EC2 instance and I have the L2 construct for that EC2 instance, it's automatically going to take care of things like creating an IAM role to stand as the instance profile. And it's going to give me some helper functions on that object that I can use for setting user data and other things that just make it significantly easier to work with when trying to create these things. And really, it's the L2s that give the CDK most of its value within the community, because it just makes creating these resource definitions and other things significantly easier. And then the L3s are usually business specific creations or encapsulations of common architectural patterns. So the common example I use is the idea of an API gateway, a Lambda function, and DynamoDB. Me as an organization, I may consider this a microservice, and I may create a microservice L3 construct that has that API gateway, Lambda, and DynamoDB in a very simple, easy to use construct that I can distribute out to dozens of teams. And I can say, well, if you need a very simple microservice for a RESTful endpoint, here's the thing to use. And the developers and the people who are using it have a very, very simple, easy to use pattern to work with.
Right, and the L3 constructs are very popular amongst the enterprise customers I've seen, because a lot of them has got the well, maybe not peculiar, but they got a unique, well, maybe not unique, but I guess uncommon security requirements. And L3 constructs is a really good way to capture those, so that every team can just do the same thing, make sure that they are always meeting the security requirements without having to just do the same work multiple times. They can just create a common L3 construct and then they reuse them. One of the things I always found a bit, I guess, interesting, or maybe it's a missed opportunity by AWS, is the fact that, well, L3 constructs are useful within the context of an organization in terms of capturing those common requirements, but there's also a lot of common patterns that, like you said, a microservice is a pattern that lots of people are repeating in terms of building REST APIs with API Gateway and Lambda, with some custom domain names and things like that, that can be probably wrapped into like some kind of an L3 construct and shared across multiple people and projects. I know there's the CDK patterns website, but it's not official and it doesn't seem to be maintained anymore. I think the patterns I looked at on there are still not supported across all the different languages. Is there some other thing that's on the horizon that's going to create more of a platform like what AWS tried to do with serverless application repository, which is just too clunky for people to use, but targeting more CDK?
The only other one that I'm really aware of that's actively being used is the Construct Hub. So as a third-party developer, as someone who creates constructs myself, anytime I go and I publish these things into NPM and PyPy and Maven and NuGet and all that, the Construct Hub will go out and scan those repositories and catalog that construct that I've created. So this has become the central place that if you want to use third-party constructs, if you want to use what someone else has created, this is the place to do it. As far as enterprises and other things go, I don't think we're going to see a big uptick anytime soon in a very common shared library of these L3 constructs, of these reusable patterns. Matt Coulter and the excellent work he did on the CDK patterns. He went out, built this thing, got a lot of people familiar with how to use this stuff. But at the end of the day, everybody's got their own specific requirements about how to do X. So what I mentioned before with the API gateway and the Lambda and the DynamoDB, that actually wouldn't work probably realistically, probably for about 70% of the people who sit there and say, oh, I want to use API gateway and I want to use a Lambda, I want to use DynamoDB. Because maybe they've got a special case where for this particular endpoint, I actually need that to drop to an SQS first. And then I need this Lambda to come off top of it. Or, well, I don't want to use API gateway. I want to use the V2 HTTP API. Or, I just want to make a minor tweak here and there. So what we've actually seen over the course of the last couple of years is that building these L3 constructs are always very, very organizationally focused. They are always about what a very small organization wants to get done. So going out and trying to find a public repository like CDK Patterns or Constructs Hub, which has a good reusable L3 construct in it, you're always going to fight up against that, because at the end of the day, everybody wants their small one little tweak to it to get it done. Oh, well, I like using Lambda and I'm going to use AWS Secrets Manager with it. Great. But what happens if I like to use someone else's Secrets Manager, Cloud Truth, or whoever it may be? Well, now all of a sudden, I probably can't use that L3 construct, so I just got to go build it myself anyway. Which is why, every year I do a community survey for the CDK, and the number of people who respond of actually using third-party constructs off the Construct Hub hasn't really moved much over the last couple of years. It's ticked up by about maybe 5 or 10 points over the course of the last 2 years, but it's not significant. Most people go looking, but they're not finding the things that they actually need. And I think that's because at the end of the day, what you need is way too very specifically focused on your particular business problem in your organization. So it's just going to always be a battle there.
Yeah, I guess that makes sense, because for an abstraction to provide value, you have to make a choice in terms of what you allow people to configure and what you hide. And if you allow them to have all the possible combinations of things, then you are back to the L1, L2 constructs that you're working with from AWS already, because that's the entire body of possible configurations you can have. So, either you just expose so much configurations that your abstraction is not providing any value, they're just creating more mass of configuration options, or you have to focus on a particular use case, a particular narrow, use case, and that's where the organization-wide conventions and requirements makes a lot of sense, but perhaps doesn't make sense when it's expanded across multiple organizations. Okay, that makes a lot of sense. And earlier you talked about one of the problems is that I guess that also goes back to why a lot of these companies are creating abstractions badly, because again, it's going back to that same friction of okay, what do we decide to hide versus what is going to be something that we think people is going to need to be able to configure and change. And a lot of times when you've got people who are not familiar, not used to building abstractions, coming in and trying to do this for the first time, they're going to make a lot of mistakes when it comes to thinking about, okay, what makes sense to be on this abstraction layer. So talking about that, one of the things that I found quite interesting was when I spoke with Mike Roberts, who is also a big CDK advocate, but more coming from more Java side of things. And one of the things he said was that CDK in the enterprise can be quite a scary prospect, because in an organization that does allow people to use different languages, and people decide to use different languages with the application, but then also with CDK, but also they often have this tendency to want to centralize a lot of the control into like a infrastructure or ops team, which means a lot of the burden have to go into the ops team to now have to maintain and I guess provide some governance on CDK projects that are written in multiple languages that they don't know themselves. Is that something that you have seen as well, working with within like an enterprise environment with CDK?
I'm going to be honest. I've been blessed. I really only deal with TypeScript and occasionally Python. I have not the type of business that Defiance Digital does is we focus on small to medium businesses. We are largely dealing with TypeScript and Python shops, and I thankfully haven't had to do a code review of Java or C# in about a decade, and I can't say that I miss it too much. I miss a lot of things about C#. Java, I haven't touched in 20 years, to be honest. But yeah, that is definitely a struggle. And it's one thing to sit there and be able to understand the API, the CDK API. It's another thing to understand the intricacies of the languages themselves and how TypeScript and JavaScript underlying it. We just had a conversation an hour ago with some of our DevOps engineers talking about how asynchronous calls work and how one slight small little change which you don't think would be a massive semantic change to the code does cause a lot of problems that you're not going to find until runtime. And this was a particular code base we were talking about, which we only get to run about once a month during a maintenance mode. So we really have to be careful that we're only going to get one shot to see if this is right. So that is definitely a struggle that I can see a lot of enterprises getting into, and I would not envy that team that would have to sit there and understand now 5 languages, toss Go in there as well, since that's been supported for about a year and a half, having to sit there and try to do those code reviews and understand all that and say, yes, you're doing everything right when you have quite a lot of differences between all those languages.
Okay, so since CDK doesn't have like a prescriptive way of doing things, and we talk about how you can do anything you want, do you have some recommendations in terms of how someone should structure their CDK project?
Yeah. So there are generally kind of 3 things that I recommend for most people when it comes to anything CDK related. First off, leverage unit testing to the best of your abilities. The testing side of the CDK is one portion that I've always really been interested in because, again, I came from an application development background. I was taught TDD 15 years ago, and I love it as a development practice. And I rely on unit tests when I'm writing my application code to ensure that it does what I want it to be doing. So when it comes to the CDK, that becomes a little bit of a different proposition because what you're not really testing is not necessarily a lot of business logic. What you're testing is, did I render TypeScript code to CloudFormation code the way that I expected it to? And that's what we generally refer to as a snapshot test. And snapshot tests are extremely high value within the CDK. It can tell you immediately if your code is deterministic. It can tell you very quickly if an upgrade to the CDK is going to cause some sort of unexpected change within CloudFormation. It can tell you right away if someone made a code change and you didn't catch it right, or they forgot to run unit tests on it and that sort of thing. So snapshot testing, we toss around every stack that we create. We just sit there and we create our stack, we go and we create our snapshot, test around it, and then that's probably the extent of most of the testing that we do. If we are building constructs within any given project, which we often do, if it's a construct that we are now bringing out into a generalized pattern to reuse across projects, then we start to introduce the fine-grained assertion testing on those things, because those fine-grained assertions are now the specs and the documentation for how that construct works. Beyond that, you've got things like integration testing and end-to-end testing, which I cover in both the book as well as the advanced CDK course. Integration testing being the process of taking a CloudFormation stack and actually deploying it into an environment to make sure that it works, because unit testing is only going to get a fairly narrow range of bugs within your code. But the integration test and actually trying to deploy a stack out into an environment is going to capture a lot of additional errors that snapshot or unit testing will never get you. And then finally, the holy grail is that end-to-end testing, going ahead and making sure that once I have the environment deployed out and I have everything out there, does it actually function together? So this is going to catch things like, did I get the correct permissions on my Lambda function to read and write to that DynamoDB table? Did I get the correct permissions on that Lambda function to read and write to an S3 bucket? Those types of things which unit testing is never going to properly catch. integration testing isn't really going to find. But if you actually run an end-to-end test, you're going to catch it really quick. So testing is definitely one of the things I say to people. The very high value just to do a snapshot test, so try to get that in early and often. Second thing would be around construct creation. And constructs are meant to represent not necessarily a specific piece of AWS infrastructure. L2s and L1 constructs, that's what they do. But when we're talking about L3 constructs, those things that are supposed to be specific to your problem, those things you should be creating early and often. So for example, if I have an ingestion pipeline that I'm creating that's going to go get information from Cost Explorer and transfer it through an ETL process to put into a database so that I can run reporting and all this sort of analytics and maybe ML and all that sort of other fun stuff on it. When I'm creating that stack that represents that ingestion pipeline, I'm not just going to create a stack and put a Lambda function in it and then an S3 bucket and an SQSQ and another Lambda function and those sorts of things. I actually want to encapsulate those different components of the pipeline in their own constructs. And the reason why I want to do that is because A, it makes it easier to read the code and easier to understand what's going on in it. Just like any sort of good encapsulation in any sort of code base, the more fine-grained you make your elements of your code, the better off you're going to be. The one thing I usually tell to people is if you're looking at a stack and you have more than about maybe 5 to 10 constructs in it, you probably need to start encapsulating these things together into your own L3 constructs and represent these things well together. I mentioned earlier the Construct Hub. Construct Hub is an open source project. It is available online. We'll provide a link, I'm sure, in the video to it and everything. And this does a really good job of representing, the various components of the Construct Hub and its ingestion pipeline and its cataloging pipeline and things with well-defined constructs. And it's a good pattern to follow with things. So early and often, create constructs more often because it's easier to break things apart than it is to collapse them back together afterwards. And then finally, sort of a general thing that I get into with it, I tend to go on the multi-stack structure deployments versus a single stack. So this is something I've debated a lot with various people on, should I have a single stack that represents all of my infrastructure or should I divide these things up? I lean towards a multi-stack setup where I have things like stateful resources that are entirely within their own stack. So if I've got an RDS database, that's probably in its own stack all by itself because I only want to apply changes to that stack when I know exactly how it's going to affect that database. I don't want to accidentally apply changes to that stack that could cause a replacement of that stack. And this is the number one thing that freaks people out about infrastructure as code in general is, oh, I'm just going and making some changes. Oh God, all of a sudden I just replaced an S3 bucket and I didn't mean to, or I replaced some sort of stateful resource and I didn't catch it because my focus was on this other thing that I was changing within the code base. So stateful resources, I tend to put in their own individual stacks, and the things that are non-stateful, I group them together by workloads and by the sort of the general business process. Beyond that, those are the tips that I give most people when they get started, and hopefully that'll get them on a good path. And for anything else, there's always both the book and the training course that covers everything else in detail.
Right. So a lot of things to unpack there. I'm so glad you talked about the testing as one of the first things that you mentioned. I guess snapshot testing kind of makes a lot of sense in that CDK can create breaking changes that you don't want that to suddenly break your application. But I always find that the kind of unit test that you're talking about, not the unit test for your application code, but for your CDK code, is strange. And I found that a bit redundant, where you write your CDK code in TypeScript, but then you're writing unit tests to assert the CloudFormation that's been generated.
Yes, I read your blog.
Yeah, which for me, I don't get it because if I have to, if I'm using CDK constructs, L2 or whatever, that should be the abstraction layer that I'm working with. If I have to know exactly what CloudFormation template is translated to, then to me, it's kind of losing the value of working with a higher level of abstraction. And it also means that all the sort of typing I say by using a high-level construct, L2 construct, I just put it right back into my test instead. And Also, I just don't think it's my job to make sure to make sure that the L2 constructs render correctly to the right CloudFormation template. That's the job of
Absolutely.
the construct creator. But do you
completely agree?
Okay, but then so in that case, do you what does your unit test look like in that case if you're not doing that kind of unit testing?
Gotcha. So let's go back to our example before of like a microservice L3 construct. So this is something that I would write some fine-grained assertions around. I'd say, okay, I'm going to create my construct and I'm going to give it a very certain set of input parameters, and I want to check to make sure I get this specific output. What I'm going to be testing in there isn't necessarily that the Lambda function, for example, got a timeout of 10 minutes because that's what I provided as a parameter. What I'm checking for is things like defaults. If I don't provide a timeout in that construct, in that initial parameters for that thing, does it render the default of 10 minutes automatically for me? And if I do provide it, does it actually accept that value and pass that down to the L2 construct? And does that render out correctly? So when we talk about the things that are being tested, you're trying to test your code, not someone else's. My code is smart default. Did I pass parameters around correctly? Are my conditionals working correctly? Are my for loops working correctly? I'm not testing to make sure that the default value of the L2 construct is what I'm getting back out of the CloudFormation code. So if I have some sort of conditional in there that says, okay, in this particular L3 construct of my API Gateway Lambda DynamoDB, I can either hand it my own Lambda function, my own whole function L2 construct to use, or it can default to a file that just happens to be existing, a Lambda handler, using a local Lambda handler on there. Well, whether it uses one or the other is the thing that I'm testing. I'm not testing to make sure that the default Lambda that it creates has all of its right parameters necessarily. I'm testing to make sure, does the logic that I put into my L3 construct, is that being applied correctly? It's one of those situations where we really don't see a similar pattern when it comes to a random CloudFormation template or Terraform, because there isn't really true imperative logic in those languages. You do have some intrinsic functions, and in fact, you do still need to test those. Back when I was doing a lot of Terraform work, that was the biggest struggle that I had with it was, I would sit there and write this Terraform module and I'd have this intrinsic function in there that said, well, if this, then I want to do 0 resources on this particular definition. And if that, then I want to do 1 of this particular resource definition. Well, I need to test that. I need to make sure that I wrote my code correctly. So I deploy it one time with the 1 parameter and okay, I got the resource I wanted. And then I deployed a second time without it and I didn't get the resource I wanted, and both of those tests passed. Well, that's kind of the same thing that I'm trying to test. I'm not trying to test, is the L2 construct working correctly? I'm testing whether the code that I gave to the L2 construct was correct.
Okay, gotcha. So you're only testing the business logic within your L3 construct. So in that case, if someone was to make a CDK application and they're not writing their own L3 construct, and they're only just declaring their resources with L1 and L2 constructs, would you still be writing those unit tests that that asserts the CloudFormation that gets outputted?
I would still write a snapshot test. I would still write a very simple 4-line snapshot test over that stack. But I wouldn't necessarily go to all the effort of writing fine-grained assertions and a whole slew of tests. I would probably just write that 1 snapshot test for that stack. And that's just my sort of sanity check to say, if something happens to change with the underlying CDK code, am I going to be aware of that before I actually deploy this out to an environment? So a good example of why I really think snapshot tests are valuable. Back around version 2.80 of the CDK, they fundamentally introduced a breaking change, which has been very rare in the version 2 of the CDK. They did this a lot in V1 because, as you said earlier, creating abstractions is difficult. By the time version 2 came out, they really had these things figured out really well, and we didn't see as many breaking changes. But back in 2.80, I think it was, they introduced a breaking change to the EKS module. The EKS module and the cluster that you created there would go out and create a role and give access to that role that was basically full-blown access to the cluster. And a secured internal security audit came back and they said, ooh, that's really against the well-architected framework and against good security practices. So they introduced this change that said, okay, we're no longer going to do that automatically for you. It was called the master's role. And the problem with that was that unless you were really keeping up to date on every single version change and every single release note that came across, you may go from version 2.65 to 2.85. You may be doing a CDK version upgrade because that's just good hygiene. And then all of a sudden you deploy out your EKS changes and you lose access to your cluster because this master's role disappeared. This is where a snapshot test would have immediately exposed that problem. You would have seen in the snapshot, the test would have failed and would have come back and be like, hey, these things got removed. And that would immediately been the red flag to go, oh, okay, I need to go now make a change to resolve this and to either add that master's role back in manually or to figure out some better way access into the system. And it doesn't happen very often, but when it does happen now, it does tend to be a potentially very destructive thing to go wrong. So that's why I say snapshot testing. They're very simple to write. I use WebStorm as my IDE, but if you use VS Code, you can use Emmet templates. In WebStorm, I use Smart templates. You can just 2 keystrokes and boom, you get a snapshot test in place for a stack that takes you less than 10 seconds to write and provides a significant amount of value long-term about the overall safety of your code.
Yeah, snapshot testing, I think that makes a lot of sense to me, especially with some of the complaints I've heard people talk about when it comes to CDK versioning changes, especially when you've got breaking changes that are hidden in a minor update. That's always fun.
Yeah.
Another thing you mentioned earlier was this idea of using multiple stacks. And normally, I'm not a fan of use of splitting out the stateful and the stateless resources because in other frameworks, like serverless framework or SAM or other things, it makes the referencing those resources very difficult. That's not so much an issue with CDK. So so long it's still within the same application in CDK application, I think you're still okay in terms of making it easy for you to reference those resources. But you mentioned the danger there of making a change that suddenly is going to replace your resource. I still fail to see how moving stateful resources into a separate stack is going to stop that from happening, because when you want to make a change to, say, DynamDB, say you're changing the schema and you didn't realize that that is a replacement, it's still gonna cause you a problem regardless of which stack the DynamDB table is in. Is there another? Am I missing something here, or is that some other angle that you're thinking about?
So let me give you a real world example of how this happens to us pretty much every day. One of our clients leverages Kubernetes and EKS. They've got RDS instances and other things like that. We set up their deployment pipeline and they run a multi-stack deployment. So EKS and everything related to EKS is in one stack, RDS is in another stack, their bucket declarations are in another stack and that sort of thing. When it comes to deploying all of this out, when it goes to all their lower environments and other things, we just deploy it out. We don't really worry about doing a whole lot of safety checks or anything because we're not making significant changes to them much anymore. But when it comes to prod, since day one, we have always put a manual review process on their change sets. So the CDK, the pipeline will kick off, it'll deploy out the change sets, and then there's a manual process where we go in there and we have to review that change set and see what the changes are that are going out, just to make sure we're not going to accidentally bring down their system, because unfortunately, we don't have good end-to-end tests. We don't have good ways of verifying that the environment is actually up and running. That entirely relies on the application team and the and the client to verify those things. So we have to be very careful about what goes out. We have to know that when we push that button, we're not bringing anything down. So we go and we have all these change sets. Well, when we look at the buckets, we want to review that change set, because if something happened to go out there wrong, then we could potentially lose information and lose that state that's in the bucket. Same thing for RDS. But when it comes to the EKS stack, we're a lot less concerned about that change set, because we know that we have a lot of automation checks in place. We know that if anything goes wrong, we'll know immediately that it goes wrong. And because the nature of how the EKS construct works out, every change you ever do to that stack always produces a list of about 15 things in the change set that always come through, because it's all backed by custom L3 Lambda handlers. So now let's imagine a scenario where we had all of those things in one stack. Well, when I go deploy out that stack, I'm going to get those like 15 different changes that are all from EKS. And it would be very easy for a change to either RDS or one of the buckets to slip in there and become missed in the noise of that EKS stack. So it makes it very simple for our DevOps engineers to sit there and go, okay, when I'm reviewing this RDS stack, I know that 99% of the time, it'll probably show no change, and that's a good thing. But if I see something in there, I know that that's probably either a change that I was very fully aware that was going into it, or a change that I definitely need to investigate more by either going back through the code and making sure that it was expected, or talking to other engineers and saying, are we sure that this RDS change is going out? And it never gets lost in the noise. Same thing with the buckets, same things with a lot of other stacks. By keeping them all very isolated, it means that when we are reviewing and we're trying to ensure that those changes are going out exactly like we want them to, that we don't get distracted by the noise that can happen with a lot of these L3 constructs and these custom things that involve a lot of Lambda handlers that are always changing, because that's how the CDK kind of does things. So it's a protection for us, because it makes it a lot simpler for us to really do our safety checks on them.
Yeah, in your situation, I can understand. But like you said, the root cause is not it's not with the ways the resources are allocated to different stacks, but it's the fact that you can't pick out those problems with your automated tests. And because you are not the ones that are doing the application development, you're the ones that are doing the deployment to production. So you can't fully trust them to do the right thing before you get to that point. But I feel like if I'm in an organization, I'm building applications, and I'm probably going to be the application developer and the person that's owning the production environment. So it feels like in that case, I really should be looking at what happens before I get to that point, rather than relying on myself or somebody else in my team to eyeball every change, or certainly the critical change that's going to touch our database. And it feels like that. For that situation, it feels like there's other things you should be doing instead of trying to, relying on separate stacks to reduce the amount of noise that you have to manually review with a change set.
I hope that I'm an edge case. I hope that I am in a unique situation that a lot of people don't get into, because it's not a great one to be in. I don't like the idea. I feel very, very scared every time we do a deployment in this environment. Like, okay, these are the same 13 changes it showed last time on the EKS stack. I really hope there wasn't something hidden in there, because, of course, CloudFormation change sets don't really give you a lot of details in a lot of situations. So yeah, I would say that what we're doing here is fairly unique, hopefully very edge case. There is one other reason why I like doing it, which again, I'm hoping that this isn't something that a lot of people come across, but it means that as we've moved more and more towards a more decoupled architectural development process, when we sit there and say, okay, this system over here is less coupled with this thing over here, and while they're related with this and in the same workload and things, this system can be kind of pushed to the next version without this one necessarily having to go along with it. Now, let's say we have everything on one single stack, and there is some problem with that stack change. There's a change that's going out and it fails for some reason. There is either an underlying AWS issue going on. Maybe some system is down. Maybe there's a bad API call that's happening. Perhaps you have some bad code that just functionally doesn't work. Perhaps some state has changed behind the scenes that's causing that CloudFormation change set to not work. We see this happen all the time when it comes to resource policies. If you have a resource policy that you're trying to set, and somehow some underlying principle or an ARN or a resource or something doesn't exist, and therefore that policy can't be validated, that's going to fail a change set. Okay, so what happens if you've got a failure over here in this one small part of your application, and now all of a sudden you need to get an emergency change pushed out into another part of your application, something that's decoupled, they're not technically highly related, but you decide to put them in the same stack. Now you're sort of in an awkward situation, right? You can't push out that change because of that unrelated error, but you don't also want to go through and do things like ClickOps to fix up the problem in the environment, because that becomes very hard to relate. So as we've moved more and more towards a highly decoupled infrastructure and architecture in our applications, I think it lends itself to not needing everything in a single stack, because I don't have to worry as much about this part of the application and this part of the application being at the same spec at the same time, because I've decoupled them. So if I separate those things out, it gives me a little bit more freedom along the way to move things at different paces. And this is just, microservices in general.
Yeah, and I guess with CDK, there's the fact that you've got the CDK where you've got a stack as part of a construct within your application, means that you can still easily reference the resources across the different stacks. Yeah, so I think with CDK, I think that's actually fine. I don't have any problem with that. But it's when it comes to things like Terraform or CloudFormation or
much harder.
Several framework as Sam, where you're creating a separate deployment unit and referencing, you have to now go to something else, or you have to use the CloudFormation, the exports, and reference that. That's where I find it creates a lot of friction, and that's where I feel that's not good enough return on investment for me to put in that effort. I think with CDK, it's actually not so bad because of the fact that it's a resource. It's variable. Yeah. It's just I can just
it does it by magic. Yeah.
Maybe not so much by magic, but certainly in terms of the abstraction you're working with the CDK application, as opposed to just a serverless project, which is mapped to a CloudFormation stack. So I think that makes sense. One of the things I do want to ask as well is, well, in that case, have you ever seen, I guess since you've been working with CDK for the last couple of years, have you seen situations where CDK is just not the right tool for the job?
I've run into a couple of situations where companies didn't want to use it. But I don't think that was necessarily because it wasn't a right tool for the job. It was more that it wasn't the right tool for the team. And that I had some personal frustrations with, because it wasn't, these guys don't want to learn TypeScript, or they don't want to learn what object-oriented programming looks like and those sorts of things. It was more, I don't think they can learn them, therefore I'm never going to let them try. Which, granted, TypeScript and object-oriented programming is not a simple concept. There is a lot of weird stuff going on. And then you toss on top of that the very weird things that can happen in JavaScript when it comes to object creation and the 15 different ways to do a for loop and all the different ways of creating objects and all these other things. It can be really daunting for a lot of people to go and pick up and learn TypeScript. So I don't knock anyone for not necessarily wanting to go down that path. I personally have never been much of a Python user. I think it's an interesting language. I don't like white space dependent languages in general. It's one of the reasons why I really despise YAML. But I think Python is an easier learning curve for a lot of people, to be honest. The only times I would say that it's probably not real beneficial to people to use the CDK is if they really want to have a ubiquitous IAC platform for everything else that includes stuff outside of AWS. So if you're doing a lot of GitHub integrations, Datadog integrations, all of these things where you are trying to coordinate everything as code, and it's not just the AWS space, but also everything that you deal with, which, as any organization knows, you might be AWS, you might be running on the cloud, you might be running on AWS's cloud. It doesn't mean that's the only provider you're dealing with. You're probably dealing with at least 6 to 4 dozen other systems on a daily basis. So if that's the path, I think the CDK for Terraform is a really good option as a similar programming model, but you get all the power of Terraform with it. The one reason why I've never really gravitated too much to it myself is because at the end of the day, I need to be able to get things done, and 99% of the work that I'm doing is on AWS. And the CDK for Terraform has never put a significant effort around their L2 and L3 constructs. So as an organization, we have to decide if we're going to go use CDK for Terraform for stuff, we now need to build all of these L2s and all of these L3s ourselves. And that's not a light lift by any means. And considering how much good stuff comes out of the CDK in its terms of its L2s and things, it's never been a huge personal motivator for me. But for larger enterprises and other things, if you're already on Terraform, I'd highly recommend digging hard onto CDK for Terraform. I think it's a highly underrated product, but I would say the same thing about Projen as well.
Yeah, that makes sense. And I guess also one of the things I wanted to ask you about as well is in the CDK book, you talk about Projen, you used it quite a lot, and in the landing page for your new advanced CDK course, you also mentioned this Projen there. I guess for folks who haven't seen it before, what is Projen? Why do we need it?
Yep. So Projen, I honestly still don't know what the correct pronunciation is. It is a construct-based API in the same way that the AWS CDK or the CDK for Terraform or CDKs is, that allows you to create these building blocks, but instead of rendering your constructs into CloudFormation code to represent AWS infrastructure, you use Projen to render files in a repository, in your code repository. So things like get ignore, get attributes, or a package.json file, potentially any file in your repository, you can leverage Projen to render those things out. So for example, the Projen ships with an AWS CDK app template or project. And not only does this give you the basic starter code for a CDK project, but it also gives you things like a GitHub action that automatically builds that code on any sort of PR so that you can verify that it passed all of your unit tests and all of this, and it just ships out of the box. Then you've got things like additional workflows you could add in very easily. This sort of also fits into that CDK for Terraform space where it's still very early on in the project. I believe the fundamentals are very strong there. Actually, I was just reviewing a video today on the upcoming CDK day here in a week. Friday. So on Friday is CDK Day 2023, and one of the talks is going to be talking about the state of Projen and what they've been up to. So Projen is fundamentally a very strong project, but the strength of it really comes in when you're willing to build out your own constructs, your own Projen constructs for maintaining things that are organization-wide. So one of our clients, they use it because they run a microservice architecture. They originally started out when we picked them up about 2 years ago. They had basically one project. It was a big monolithic application. And over the course of the last couple of years, they've been splitting these things to small sub projects. Every one of those is its own Git repository. All of those have to follow the same SDLC process with the same workflows, the same PR checks, all these things. We've baked that all into a very simple project. If they want to start up a new project, they use one command line, and out of that, they get all the GitHub action workflows, all the basic starter files for a Python project or a Node project or whatever they're trying to build, like a static website and things like that. Very simple to maintain these things long term. Now, the advantage of the project or something like this over top of something like Yeoman, problem with Yeoman or any of these sort of like clone or repository processes is you do it the one time, but then from then on out, once you do it that first time, you own all of those files from then on out. And if there is a fundamental change to, say, like a GitHub action, you now have to have some sort of weird process where, okay, here's the source of record in this. Now I go PR that file into all of the other projects, or copy and paste it, or somehow take some code block and merge it in with the rest of the other code blocks in a file and all this other stuff. They can be a very horrible maintenance nightmare. Projen takes ownership of that file from day one to day end. So if you need to make changes to that file, you do it through the Projen interface and through the API, so that if you need to upgrade your project over time, you can do that very easily. We do updates to their underlying Projen project probably about 2 to 3 times a month. All of their other projects just have to update their dependency on that Projen project, rerun one command, and you get the latest version of all those definitions very, very easily, very simply. Takes 30 seconds, and we can automate it if we ever put the time behind it.
Okay, so it's I guess a very useful templating thing for your tool for your projects.
Yep.
So another thing I guess I wanted to ask is, it's been 2 years. It's about, I guess, almost 2 years since CDK version 2 has become a GA. What do you think are the biggest missing pieces in CDK right now, and what are the biggest things that the CDK team should be working on?
The CDK still lacks a little bit in its L2 support. There are still many, many services within AWS that don't have good representation in the L2 space. So you can still use the CDK to provision resources, but you're going to be using those L1 resources, the straight one-to-one CloudFormation mappings, which aren't the easiest things to work with. You have to manually handle references and everything all back and forth yourself. There's no grant methods for easy least permissive permissioning and things like that. So good support for, or continued support for L2s, and making sure that the open source project contribution pipeline is solid is, I think, their biggest struggle right now. They are making changes on their side. We've seen this on the cdk.dev Slack server. They've mentioned a couple of times that they are working on this process, and they're trying to make it better and easier for outside contributors to add to the project, like a good open source maintainer should be doing. Beyond that, there are probably some wish list items, but for the most part, I think the CDK is pretty mature. And other than just continued good guidance on the right way to do things and how to avoid the wrong way to do things, I don't think there's a whole lot more else they could do from a technical standpoint. It's really just education and community support at this point that I think they need to work on.
Right. And I guess it's kind of interesting as well that you got things like SST, which is building on top of CDK, but adding more sort of, I guess, almost a more opinionated take on how to do certain features, and giving you some nice abstractions that you can do a cron or like a scheduled job thing, and it would automatically turn that into a cron that triggers, I think, a code build, because that's the easiest and cheapest way to run containers on AWS. Or at least Corey Queen's favorite container service. So I think SST is doing some really interesting stuff on top of CDK, but also the creator of CDK has now been working on a new project called Winglang. Have you had a chance to play around with that? Have you got any thoughts on what is it, and does it look like something that's that's got legs to stand on?
Yeah, absolutely. So Alad Ben Israel, he left AWS. I think it was at the beginning of 2022, and he went off and created Monada, and which has now been rebranded as Wing, and their main product is Winglang. So the goal of Winglang was to really try to take what he had started with the CDK, which was bring a more programmatic model to infrastructure as code, and take it to what the next level is. At the forward of the CDK book, he actually wrote out, the 4 directions he saw the CDK moving in. And this is, I think, the culmination of one of those directions. So for anyone who hasn't seen it, Winglang is what I would call a infrastructure with code system. So similar to what we saw with SST, with AMPed, I believe, as well as Sam Goodwin's functionless product that he was working on last year. Wing's goal is to remove that separation that has existed for the last 10 years between your runtime code and your infrastructure definition code. So a classic example that they have up on their site is that you've got one single file, and in that file, you start off the top and you define things like an SQSQ or a Lambda function or an API gateway endpoint. And then the code that actually functions at runtime for the Lambda handlers and for other things exists right there in that same code base. So as a developer, everything that I'm doing is within sort of the same headspace. I don't have to sit there and jump between this file that's my Lambda handler and this file over here that defines my infrastructure that supports that handler. It is all within the same code base, so it's easier to reason about what things are doing. But then you take that to the next couple of steps, which is when it's all in the same code file and it is a new language that they're developing called Wing, you now get the advantage of a compiler that can actually infer a lot of things for the developer. So currently, if I have a Lambda function that needs to interface with an S3 bucket, well, I'm not going to hard code the S3 bucket name into my Lambda handler. That's bad practice. I'm probably going to pass it in as either an environment variable. Maybe I use an SSM parameter that I read at runtime. Maybe it's in a secret, something like that. Well, if I have that bucket that's declared right there in the same file as the Lambda function that uses it, the compiler can take care of handing that information over to the Lambda handler for me. So I don't have to worry about writing up all this sort of glue code that I've typically have to do a lot right now within my code base. I can also do things like infer the permissions that Lambda function needs. So if it looks at that Lambda function and it sees in there that it has a call to an S3 bucket to get information, well, it knows that Lambda function then needs to have get permissions to do it. I don't have to worry about that as a developer. The compiler can then infer that from my code. The other big advantage, two of them really. So first big advantage, thing that they're doing that I think is really, really cool and really probably one of the most distinguishing and powerful features of the whole thing is that they are shipping it with a console that allows me to simulate a cloud on my local machine. Now, this isn't emulation like local stack or other things. It's not an emulation or a containerized runtime like what SAM does for Lambda functions. It is a simulation of all of these cloud resources. So I can do this when I'm sitting on a plane, when I'm sitting in a crappy Wi-Fi, whatever it may be. And I can do full end-to-end testing of everything. This console allows me access to see my API gateway type of end source, my HTTP endpoint. It allows me to post a message to it or make a GET request. It allows me to sit there and see how that message traverses all the way through the system, debug it all along the way. And the goal there was really to fix the problem that serverless and MSPs introduced over the course of the last 10 to 15 years, which was we took all of these application logical functions, things like queues and bucket storage and HTTP endpoints and all these things, and we took them from being within our code base and within our application code to outside of them. And when we did that, we introduced a very, very long inner development loop cycle into what we were doing. So it used to be 10 years ago when I was a .NET developer, everything was on my laptop. And if I want to debug an application, if I want to develop this thing full end-to-end, I've got everything on my one machine to do it. Well, that's not really the case anymore with serverless. If I want to sit there and I have, a Lambda function that works with SQS and hits a step function and hits maybe glue or a media transcoder or things like that, I actually have to deploy to the cloud to be able to test that end-to-end. To be able to say, as a developer, I've done my job correctly. So now all of our developers have to have their own sandbox accounts, and they have to have access at all times to those things. And then every time I make a change, I got to wait for 1.5 minutes for that deployment to go out. And it really slowed me down very much as a developer to the point where I've got very specific workflows when I'm doing with the Lambdas to make sure that I'm as quick as I possibly can when developing a Lambda function. So the goal of Wing was really to try to bring that development experience of a monolithic application back to the developer, despite the fact that they're going to be actually deploying out to a cloud. And then that's the final thing that's actually really cool about Wing is that I develop all this, I define all these things, I build all of this, but I haven't actually chosen a cloud. It's actually after I've built everything that I choose, do I want to deploy this to AWS or GCP or Azure? Because ultimately, all of these cloud providers have basically the same services and basically the same MSPs, and there are consistent and common interfaces between them. So that can be abstracted away. So very cool system. I think they've got a lot of potential. I think they are going to they've been doing a lot of tremendous development over the course of about the last 6 months. I'm really excited to see what they can show off towards the end of the year. I think you're going to see some really cool people building some really, really neat things on it, and be happy to have an experience where they feel like they're going quickly again, where they feel like they're iterating like a startup type of developer should be iterating.
Yeah, if you just worry about iterating on your Lambda function, you should really check out the stuff I've been teaching in terms of remote code testing, because I don't wait for a minute or a half to deploy my code every time I make a change. I just test them from local. I can debug them. I can step through the code as well. But I do like some of the things the idea that the Wing and Amped is promoting, this idea of being able to just have that faster feedback loop and not having to understand some of the underlying decisions and the cloud resources and things like that, and be able to make optimizations on your behalf, because you're abstracted away from some of the underlying decisions. But I'm also very dubious about the approach and what it actually means in practice, especially when you're essentially separating the development, the author time and the operational time thinking, and I'm not sure people are really ready for that, unless the abstraction layer is complete from the operational point of view as well. That if I'm authoring one thing, it compiles to a bunch of different AWS resources that I'm not familiar with myself, or maybe I'm choosing a different cloud that. Operating in the cloud is not just a case of knowing what resources and what queues are there. There's a lot more than that on the operational, certainly in terms of the operational side of things, understanding service limitations, and even just knowing who to contact when things go wrong. Those things are not easy and not straightforward, and you don't think about them until you're in production and things are going wrong. And so it's my main concern with a lot of those tools is just this kind of split brain of what you need to know at author time versus what you need to know or they're trying to hide from you. The question is how successfully they're able to hide that from you in terms of the real responsibility that you got to deal with. Because if something is going wrong with, say, with SNS or API Gateway or whatever, do I even know that that's what my application is using? Do I even know where to look at for the metrics? Do I even know who to, where do I issue a support ticket to ask for help and to complain to find out, do I even know to where dashboards I need to look at to see, what's the current status in the US is one, even though Amazon's probably not going to report it anyway. They're not very good at timely updates on the outages. But things like that, you need to know the decision that's been made. I can see how you can accelerate a lot of that development time, but again, as someone who's always had to be on call for things, I always worry about, writing code, that's the one part that's the easy part, but keeping things live and running, oftentimes that's the thing that wakes me up at night, because my pages goes off. So that's the part I worry about, but I'm very curious in terms of just what the Amped and the Wingland can do, and some of the things they're doing is really amazing. I have to say I'm really intrigued, but I have to be cautious, and I have to temper my excitement and actually see what it means in practice, and how much they're able to sort of, I guess, free themselves from the constraints of the underlying cloud platform themselves.
Yeah, I just want to toss in a little bit at the end. I know the Winglang team. I know the guys that have been working over there on the Men and Limit. They are some of the smartest, most dedicated people that I've seen. If anybody can pull off the very big mountain they are trying to climb, I'm sure they will. And as far as Jeremy Daly and Amped, I think that guy's got a really sharp mind for what the cloud space is like. And while he and I disagree wholeheartly on what the CDK is and its value within the system, I'm very excited for what he's doing, and I can't wait to see his product in the market now, since he launched last week. And I'm going to be playing with it this week and trying to build a couple of things with it, because I think it's really cool.
Yeah, I'm really excited for what Jeremy is doing as well. He's a really smart guy, really knows the serverless space really well. and he's been working with the serverless team as well, the serverless framework team as well, for a while. So really excited for what he's doing with AMPed. Even though again I'm a bit of a skeptic, but yeah, I'm going to try it out myself as well. Oh yeah, I guess we are really over time, but Matt, thank you so much for taking the time and answering all my
Thanks for
questions
having me.
about CDK.
Anytime.
So your course, I will have the links to the course in the description below. So anyone who wants to try it out, you can go and download it there. Anything else that you want to add before we go? Any other anything you're doing, maybe for reInvent?
I will be speaking at reInvent, a talk on what I've learned over the course of the last 4 years of using the CDK. I do have my course online, as well as still the CDK book if you are more favored towards reading your learning material rather than listening or watching a video. And otherwise, if you've ever got any questions or problems working with CDK, then we've got the cdk.dev website and the related Slack server. We'd love to have everyone join in over there. And we try to do our best over there to answer everybody's questions.
Great. I've put that link in the description below as well, so you can go and reach out to the cdk.dev website, and I guess you'll find Matt's social links down below as well, so you can always reach out to him on the Twitter and ask him questions directly.
Yep, Twitter's a good place, although I probably talk too much about dogs and Star Trek for a lot of CDK people.
Okay, sounds good. All right, Matt, it's been a pleasure talking to you. I hope to see you sometime soon, and best of luck at the CDK Day.
Thank you very much. Appreciate it.
Cheers. Okay, bye-bye.
Bye.